Hello everyone. This video I begin to review some detail from the previous video because the coordinate detail I will teaching you this video. And last video I introduced this mental session, assembly session, and a parallel session and single session. Finally, in that video, I will propose some question. I created a production line and reuse the palette in that process. And I leave the question in that video. How many the pallets reuse in the loop of the production line, how many pallets should be used, right? Okay, right now I will continue asking that detail, right? Detail in this video. And last time you have known about how to use the assembly station. Assembly station try to assemble two workpiece, two parts, right? Assemble together. Use the special function, the special option, attach, right? Send and feed to the conveyor. The conveyor, the carry the object to the end of the conveyor and supply to the dismantle station. Dismantle station use the option detach and pitch out the pallet and the part attached together before, and now split it out. And one pallet press above buffer, and the other press below buffer, right? And the pallet carry on continuous move to the buffer to left side, right? Try to reuse again, feed to the assembly. Right? So far you haven't known how many the pallet should be used because it's not clear, right? Let me use the user interface, right? And use the chart. Right? The chart I press on this, double click on here, click on here, and you will set up the parameter inside, right? Okay, let me look at the position line before. Okay, this one is a 3, right? 3. Okay, I will show up and set up in this to a number of this. I use just only one, right? First, and again I double click on the chart. It show up, show. Okay, sorry, not yet. Press the assembly station to here. Click OK. Okay, reset the key and play again. And right now, assembly station not good, right? Not good because use and work utilization was working, not completed 100%. Right now, use just only 30%, right? 30%, not enough for the assembly station. It's not completed, not perfect, and complete the performance from this machine. It's not good. Okay, just only 30%. Let me adjust the main part. I feed more, create a number of the part more. I use 2. Click OK and reset first and rerun again. Okay, increase the percent to 60%, and okay, approximate 60 and 70%, and okay, gradually reducing, right? You see, it's and ripple, and where ripple display the percent 50 to 60, right, percent. Okay, that means not enough, right? And the 2 parent not enough for this process. Okay, let me adjust. Okay, add one more, the part 3. Okay, you look at here. Okay, little bit. Okay, in the right, this is fraction, right? Fraction, right? It's fraction, not continuous enough. Okay, working and drop, and okay, waiting time created, a little bit too in period time. That means it's not continuous, it's not yet 100%, right? Uh, so I should add one more, right? For okay, three palette. Okay, it's not 100%. It's just only 80%, 90%, right? I try. Add one more the palette to the result. Result is feed to the assembly session for assembling in another part from the sub part session. Fill in this blank. 4. Okay, enough. Yes, okay, I reduce the speed. Okay, that just enough for 4 palette. If you put in 5, okay, 5 palette, maybe maybe uh, maybe some palette stand by one of all station in the production line, because it's 5, right? 5 is I think is offer. You try to analyze, right? You try to analyze, right? You try to analyze because this station I use process, right? Process time for 10. And this is 10 seconds for this processing in here. Okay, it take 10 seconds. And this one, double click on here and uh, time use range, and then time is 8, right? 8 seconds, 8 seconds, 8 seconds. And this one 8 seconds. The time, the time speed, right? 1 meter per second, and this is time equals, and okay, speed up here, and user processing is 8 seconds, and this one 10 seconds, okay, and 10 and 8, 10 and this 10, right? And fully on the production line process is the use 10. Then that means 110 is 110 out of this become summarized to 4, right? 4 piece use the 10 processing time to build and manage and something, right? It's make it the product, assembling or something, and use 10 seconds, and it carry in the part one place to another place, right? At the end, you have a dismantle. I use the 10, right? 10. Okay, that's why this system should be used for parallel, right? Because 10. The 10 is the 110 for one pallet. If this pallet still here, right? Still here is 10. Imagine, okay, the one pallet stay here. There is the assembly, and another is carry on by the conveyor. Is 10, right? Is one pallet. Is another pallet placed on the dismantle station. And last one pallet, right? Okay, say on turn back the conveyor, right? Turn back conveyor is just the only one. If you put in 5, okay, 5 that should be here in the buffer is waiting, right? Right, the standby pallet, standby right here. Okay, that's it. And okay, focus on display. Right? Display, you can double click on here. You can just setting a bit for display. If you use display in frame, right? Okay, right, the built-in in the background, right here, right here, apply. Okay, right here. When I show it, show here and run. Show over here. Okay, if I adjust some parameter and look at the chart, and the chart is show me right in the 3D, because right now I working in the 3D model, right? Double click on here again and click on 3D, and you can adjust little bit in the 3D dialog box, right? Okay, this is the 3D dialog box. You can adjust this frame. Okay, look at dialog box. You move your mouse, focus on rotation. The rotation I just use 1 right now. Default the -C, right? Okay, I just use 0 and 1. 1 put in the band x-axis, right? And this move 90 degree, right? Okay, 90 degree show up. Okay, like the vertical direction, move and stand, right? To C axis, right? You focus on the axis, the Cartesian coordinate axis, right? X, Y, Z. Okay, move, stand up, right? Right, stand up, and I move up, right? Little bit move up, show up on C, because you rotate around of x-axis, right? And I move up prime 4, right? 4. okay, it's just 14, and okay, press and fold over the plow and the pen. Okay, click OK. You can use keyboard direction, up, down, left, right. You can use the keyboard button. Keyboard is go up, go up here. Like this. Display and side, right? Okay, side, side, side. Axis, display, data, 3D. Okay, just orientation and position, right? Or you fill in exactly number to x and y for the position, uh, or you move by keyboard. Go left, go right, go up, go down, right? Okay, two way. Either you use keyboard or use the exactly fill in the blank box in the position, right? So and you can use. Let me return back and again try to use, so and use by yourself. However, you can change the color, and you have known this before, because I thought you some problem and use the chart pop up and show you in the frame and show you in the normal frame. Okay, both. I just taught you before. You can adjust and put in and learning by doing by yourself. You can go here and display scale, right? The label, view in the label in the chart. Going the scale up, scale down, and right now default put in one. Okay, you can scale up, scale down, bigger and smaller. You can off the chart. You can use this option to adjust the size of the chart. Reset, reset to start point again. And this time you can need the frame, right? The frame. You can adjust width and height of the chart, right? Okay, you can expand and reduce the size, whatever. You can go for it. Yeah, you can go for it. And another way, you can scale up, scale down. This is you can adjust the size of the chart, right? Okay, this display in the frame, right? In here, in width and height, uh, or adjust it 3D. Let me save, right? Okay, this one, including the chart, right? From the previous video, this time, okay, the beginning time, I propose how you use the user interface in the chart, and adjust the chart correctly come to 3D display the wall, some wall in the industrial line, in the position line. Okay, next topic I will show you in another object. uh, right now you save it again, and create the new model, because I need to keep it here for example. Maybe sometime you need to review by yourself what the object you have learned before. You review by yourself again. That means why I create a new frame. Okay, every the model put in this directory, right? This the directory, right? And this the folder, right? The folder, okay, put fill in. And one more, I use the model frame right, and rename this, and we come to pick and paste, pick and paste, pick this, pick, place. Okay. We're gonna go material 4 for drag the in necessary object in process. This sort is important for process. Okay. After you done this, then drop on here, and the new one object I need to suggest you in the process, the production line, that drop in robot over here, is here, and in okay, and the output train receive the output that come out of the robot. This time is the really basic process. This is a robot for pick and paste. Maybe if you have the next station, right, the conveyor, you can pick the object by robot, pick and place on the conveyor. Or the next station, right, in the assembly, you can take the robot pick the object from one place to another place at the assembly station. And right now, click the connector from source to robot and the robot to brain. Try to replay how to play this process. Click on here. This is the default value, default parameter. I just connector. Take the connector, connect 1 to 1, right? Robot to drain. Right? That's it. And what is time, the process time of the robot? You can double click on here. Look at the data on the command, the robot, right? Here. If you, okay, I just need the robot compare with the robot of the station. What difference between robot and the station? You see in the attribute of the robot station, for the station, right? For the station, robot and station different, right? Okay, different. In the robot, failure setup is gone, right? It's gone. Setup is gone. Never have the setup tab, right? And this time the robot, okay, already there is the tab attribute, right? Attribute and time is gone, setup is gone, right? And control axis, that thing. and important energy and cost. Okay, the same of the station and robot. Different, just only two. There are two steps and different from station. Time or time is actually also have in the time table, right? In the time, posting time, right? And for robot defined by the table, time table, angle table. That means why the time in the tab time is gone in the robot, because take the command, the parameter in the time, fill inside of the attribute, right? Inside of the time table button. Okay, you compare, and the tab else, okay, the same of the session. Okay, let me cancel and delete it one now. Look at the tab table. Okay, this is the default, right? Default robot. I already replay and play the simulated uh, for you already, right? And clear more if you need to know about the time, right? The default angle, 0, this is 0, and the default posture of the robot. It's turned, right, in the robot, in the front of the robot, fed to drain is the output, right? This is the default position for now. And default position going to move from drain, right? Move from drain and push to sort. Use 6 seconds. 6 seconds, right? 6 seconds. And the sort move to drain and come back again. Use 6 seconds. Right? 6 seconds. A drain to sort, right? The drain to sort 6 seconds. And this is the default. Default the time process for this robot. You can adjust. In this box. If you need to define new time, new time is the process of the robot. How is robot move? How far the robot move one place to another place, and actually you can use another program for testing, for define the point, define the trajectory and the type of movement, like linear and circular, right? And how speed when the robot moves step to another step you can define by another program, and you take on of the time, right? And average time put into this robot in the pan simulation, because pan simulation robot is not go in the detail of the robot, right? Exactly, right? It not go in depth of the robot detail, just use the time, the time, evaluate time, the average time, right? You need to average time. You need to define the time, right? In the another program. If inside of the technometric program, there are two programs mostly used in the industrial. One, pan simulation, and right now I already learned here is being learning, right? And another use the process simulate. Process simulate focus on the robot, right? This is another program. You can define the part, define trajectory of the robot, define the joint movement type, right? One a linear, circular, something. Okay, this is the example. And right now in pan simulation, you just only total the time when the point to point total the time, and how the robot move, right? In the detail inside. Okay, pan simulation never use that detail, right? Okay, you take this this rule, right? This rule in in your understanding, right, of the configuration, and just enough for analyzing the process already, right? Enough, right? Because I need the time, the point to another point, move from one point. That's it enough, right, for the configuration, because it's overall detail in the process, right? In the position line. That's enough. You need to know about how many robot should be used in your process, your process, because your process is very complicated. And how many robot, if you need to take a lot of the robot, how many robot you should use, you need to analyze, right? Analyze by simple simulation, and that's it, right? And the robot, okay, use the time process, use the time process enough for uh, some some effectiveness in that time, in that station, because you analyze, right? You need to approach, you need to produce the product, approach to the tag time, the customer request, right? The requirement of the customer. You need to define the robot speed, right? Okay, you need to take the robot, and how many the robot use in producing and moving, pick and paid and everything, right? Analyze the time, right? Okay, analyze the time of the robot processing in that station, that process, and you define that robot. That means, okay, the total time is enough for configuration. If you need to go inside the detail of the robot in depth, you need to use another program for analyze, especially learn the study in the robot, right? Specific program. That's the program. If I have some time, I show you how to use the processing to define the robot, and just only the robot, because okay, the passive need evaluate average time, need average time enough for passive, but okay, that total the time, where is the come from that time. Okay, go back to the special program, analyze why uh, why the time is come from, right? And where is that time is come from, you analyze, because it's a step by two step. Analyze is the type of the type of the movement of the type is there. I type the circular and linear, right? I told you before, like that. You analyze and define the point to point, right? Point to point, and how accelerate, right? When move point one to point two, how much acceleration, right? How much is the velocity. You can define the spatial program, something like that. Okay, right now I focus on evaluate time, in total the time, right? Okay, if I change to here to 6 to 10, 6 to 10, right? Angle, default angle, the sort is 10, right? And default to sort, right? And this time default position, the robot is face to the drain, right? Okay, apply. Yes, I use it one. 20. Click OK. Apply again. Okay. Play. Okay. Father. I need to slower. Okay, adjust this one to come to one. Apply, play. Okay, in the timetable, tell you use 10, right? 10. They forgot on here. Move here, 6, right? And turn back. Okay, I bring you to the parameter again, timetable. And the default, this is the default position. Going to the sort, right? Going to the sort. 20, 20 seconds. And the sort come back to 10, right? Come back to 10. Come back to 10, use 6, right? And use 6. Okay. Oh, sorry. Let me use another function. Use the event controller. The event controller block, right? Okay, you show it show in the panel. The panel it can be used for play, and start and stop, and start full speed simulation, and go to is the end, and go to start fast forward to uh, the end, and another step, right? Step by step. Of before that, before I propose the frame timetable. Start default, go to the sort, right? And this position, go to the sort 10 seconds, right? And the sort go to okay, sort go to drain, right? Sort go to drain. Look at the table. Sort the angle, right? The default angle to sort, right? Angle to and default angle to sort from here to here is sort. Use 10 seconds and sort, right? To drain sort to drain in this column, sort to drain use 6 seconds. Sort to drain use 6 seconds. And drain, right? And drain to sort, right? Drain to sort 20 seconds, and turn back to the sort again, use 20 seconds, right? Okay, so I will show you and use the step, right? Use the step running. Okay, yeah, you click again because step number one, we didn't see the step, right? And I suggest you go next. Okay, step number two, sort come here, and the part it come in to the sort, right? And next, go and go again. Turn. This is step number one, 10 seconds, right? 10 seconds. It's a 10 seconds. Go next step, right? More. Next step. More, right? And more. Next and next again. And go again back to the drain. 6 seconds. Plus 6 seconds. And go next, and next step, and next step, right? And next step. Okay, it work piece gone, and next turn back to the sort again. 20, 16 seconds plus 20 seconds become to 36 seconds, right? Okay, this is the meaning of the timetable. Right? Okay, double click here, the timetable, right? 10, 6, 20, 10, right? And default angle to 10, and 10 to drain, that's it. and drain, right, second column to sort, right, to sort 20 seconds. Default is default refers to drain, right? Here the default position. If sometime if I need to change the default position, change the default position, can I do it? How do I do? I double click on here. Uh, I use 3D, right? 3D. Write the chart, right? And the begin, the time, the early this video I taught you about how to use the chart and move the chart and change the position orientation, change 90 degree around of the x-axis and move to place on the wall, right? And the same thing in here. Right here I bring you to this dialog box. This is the 3D, right? 3D, and I need to change and change the position of the robot, and I set up the new position of default, right? Of default. I will change, okay, rotate around of z-axis -1, accepted. And if I use 80, 180, 180, apply. And now the robot turn around of itself, move, right, and move to another default, new default position, right, and then the robot arm face to the sword already, right? The sword already. Okay, I click OK. Click OK. And something when you click the robot and change the robot default position, the line, right? This is one, right? Because this one, the sword, this the connector, right? The connector. You must delete again because the connector previous posture for the connector, the old connector, and this one for the first posture, right, of the robot. And right now I suggest you should delete it out of the connector, right, and wiring again, renew, wiring the connector again here. I double click and change timetable, default, this is the default position, change, right, because it's the opposite direction from the first posture. Default to sort, right, and I need to change. I will adjust the time table, the default angle. Right now the robot arm pose default posture. Default posture move to the side. Okay, it's closer than the first posture, right? I will define 3. Going to sort to drain U20. 3 and drain, come back to sort again, come back to sort again. Okay, faster than the sort to drain the first time. Sort to drain first time 20 seconds. And right now drain, come back to sort, use just only 10. Just only 10 seconds now. Click OK, apply, click OK again, and pray. Use the event controller. Click the single step. 3, right? 3 seconds. Right? Okay, this is the default angle. Move to sort, and sort, come back to drain, and drain, come back to sort again. Okay, next step. Go to the drain, because it's a whole object, maybe heavy object, right? Use the longer time. Okay, 20 seconds plus 3, right? Become to 23 seconds, and you come back to pick up the next object again, right? The second number 2, use just 10. Use just 10 seconds. Really sure, and the 23 become to 10, right? After I done about move to sort again. 33, right? 33. Come back again. This way you define the timetable. Very easy. Easy, and you make yourself understand about timetable first. It says, and pray, and continuous pray. You see, look at the double feed forward, right? A little feed forward, double. Come back again. You notice about the symbol when you pray, right? It's the double feed forward. Double feed forward, right? The program, the program, okay, to help you, and okay, the automatic faster, because the protein and save the time, and that symbol, right? Okay, and this is program generated and high speed, faster than the default speed, right? Faster than default speed. This is automatic built up by this program. If you need to adjust some parameter, and go on about the real situation, the real time speed, something, right? Okay, you can click on here and turn off marker over here, off, right? Turn off, click turn off, and right now you're going to look at your process, right? And look out and always tracking the posture and movement of the robot. It's not just program is running automatic, right? Automatic is gone, right? Because you click it off already. Okay, see, takes a long time, 20 seconds, 20 seconds. And right now never have double feed, automatic feed faster anymore. Never have, right now. Right? Okay, come back. For me, I need faster. Skip at the time. Okay, it's unuseful. I skip it off. Right? Keep over, and faster is better for me. Okay, keep okay. By the way, you can enter to the edit 3D property. You can click right button, going to edit 3D property. You found about this dialog box, right? Dialog box. This is the way number 2. Way number 1, you can double click on here, click the 3D, right? Okay, it pop up the same dialog box. You can adjust the orientation and position of the robot, right? Adjust and change the default position. You can use this dialog box, and they will adjust the position. Okay, you click on cancel. Okay, way number two, right button and edit property. Next topic, I will show you if you use the robot uh, going to do something different from website. Uh, Website is over here. Okay, pick and place. And if the robot pick the sort from the sort, pick the object from the sort, paste on the conveyor. What happened? What do I do? Right? Click the robot here and use the conveyor. Use the conveyor here. Finish. And that come in the red cycle. I use the connector wire 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 the saw to the robot, and the robot how to setting how to set some parameter at the conveyor for receiving, for getting the object from the robot. Okay, double click on here on robot because x axis, right? X axis the robot is come out of the robot, press on the conveyor, right? That you must go into axis, the exit in the tab, right? Exit tab, going to set up the option target selection and target selection and the default exit strategy or target control. Okay, this is the default. And look up inside the place part as sensor and load part on MU as sensor. Right? And need to place part, right, in at the sensor. The sensor mean detecting the position detecting the position along along length of the conveyor. If you place the sensor at the middle and the robot placed at the middle, depend on the sensor position. And let me use this sensor first. The target, what is the target? The target is the conveyor, right? Let me drag drop on here. This is the target. I define axis tab already. Define how your robot press on the conveyor. I define already, and the conveyor is the target, the object press to. Right? Okay, already here, and the sensor number not yet. I never created the sensor before. And if I define the sensor and the first time for this model, right, then there must be one for sure, right? Okay, I set up one first, or okay, waiting me create the sensor location first. Okay, come back again, define one, apply. Okay, I define the robot, right, already. I just double click. This is the conveyor. I need to define the position of the conveyor. I just create it. Click right button. Click right button. Double click on here. Click right button. Create sensor. Right. Okay, it's create sensor. Okay, click when you move your mouse, focus on where you need to define the position of the sensor. You click on here, click right button, create sensor, create sensor. Click right button, add the position you need to place on the sensor, create sensor, create sensor. This is the distance, distance of the conveyor. You define the position at 0.207 made. Click apply, click OK. This is the position, right? The position, the position for where the robot take the part press on. This one, this location. This is the sensor. Zoom in. We will click on sensor. This one. This sensor ID is 1. ID 1, right? It's ID 1. Okay, you can place your mouse very close at the position of the sensor. Okay, ID 1, right? Okay, you come back the robot again and press axis and 1 and 1. Apply. Okay. Try to use. You notice something in the left side. This is the drain. You can define the connector from the robot to output drain, right? For this, the right side robot to the conveyor, you cannot define the connector. You must use the parameter. Where the parameter specially. Okay, use specially of the tab axis, axis defined right here, and define the position of the sensor as well. Okay, let me use the panel play. It's pop up message error. Ankle, right? Ankle table not yet completed. Not yet completed mean I never set up the ankle table anymore, right? Okay, I just come back, right? Come back to ankle table. Okay, come back to ankle table. Double click here, ankle table. You click on here and press enter. Add the new row. Add new row under the sort. And this sort here, sort behind, paste behind of the robot. It's not front of the robot, right? Because I never yet change the default position of the robot, right? Not yet. I just use the default. I never change the robot position, right? That means why the sort 180 degree, and this one I drag drop on the sort, right? This you can use the conveyor. The conveyor I define zero, right? Zero angle. This is the conveyor. Apply. Try. I'm not sure the name is not purely conveyor, and okay, it is including about model.pick paste, right? I'm not sure. I will try. It can be used that parameter or not. Pay. These are not completed, not yet. Stop simulation. Yes. Come back, define the anchor table. Hmm? Okay, I enter. That drop, drag to here and define 0. Apply. Okay. Apply again. Okay. Finish. Just okay. Further. Come back. Uh, Double click in the first one, the left zone, the first robot, right? The angle define the source and drain. It is the default, and this one, the right zone, the robot, second robot. You cannot define uh, the table automatically because I cannot define the connector from the robot to the conveyor, right? I use the sensor instead. That means why I take dragging about the robot, the conveyor to here by manual, right? Next, because the output from the conveyor and stop, right, never release out of the robot, of the conveyor, right? Okay, let me take the drain, connect to the conveyor. Okay, it's flow smoothly, and the output drop to the drain output, not never have a traffic bass busy on and got stuck on the conveyor anymore, right? And right now it's flow smoothly because the drain receives the output object. For the object robot, I will stop for now, and I will list the example specially for you later. And that problem you must use on off the object I taught you before, and combine together and mix together so that the problem special production line example. Right? And right now I need to go on next object. You must learn before I goes to the example special. Okay, let me save this file first and create a new frame, uh, and rename storage. Okay, storage. Storage. Click OK. You press the sort. The sort is very important. Very important. You must use every model. You must use this one, and inevitably inev imperative, right? Imperative uh, object you must use any time when you created the model, right? Important. And next object you must learn storage. Here storage is storage. uh, connect to the storage, right? Double click inside of this object, You can define a number of storage in this object. And if you use the object inside of storage a lot and cost your computer resource of bearing the resource consume your resource a lot, right? Consume your resource a lot, causing your display get stuck and cannot move smoothly when you tracking and move viewer by 3D view and move orientation and variable movement of the viewer. You cannot and got stuck, always got stuck and okay awkward to movement. Right? I will try for you. Look at here and 50. And be careful. You be careful if you set up a lot. They consume a lot of your resource, computer resource, and computer hang, maybe hang and stop, got stuck, right? Got stuck a long time. You cannot move your mouse anymore and got stuck. Maybe you force in task this program. Be careful. And for me, I just test for you 30. Okay, apply. Okay, enough. My computer now. You can test up your graphic card enough for CAD model or not. You fill in 100 per 100, right? You can test. And working again. Ready to play. We play. Play. Still smoothly. Still be smoothly for me. Okay. 10. Move. 50. 50. Still smooth. Still be smoothly movement my mouse. 10. Start. Okay, not, it didn't be smooth enough. We just got stuck a little bit. Okay, you be careful your computer. But you need to test your graphic card and your computer. Okay, you can. And right now 50. Okay, enough for me. 50 and 10. I turn back. Okay, let me use test. By the way, if you need to see your computer performance, okay, you press F on your keyboard and display your computer property. You see frame per sec, 6.9, and graphic card for me is normal. It's not. I never have the external graphic card anymore, right? And this one is a built-in graphic card in my computer. It's not good. It's not good. Okay, I use OpenGL version 3.3. Okay, if you press F again, it's hidden. It's hidden. Let me play back and reset, right? Double click on here. Use it. Okay, by the way, I will tell you a little bit, and uh, you see the object, right? Limited by license, right? License type. If license type and the student license in the limited object at 80, right? And this one is the object mu part is not including about is not including about the license limitation, right? It not depend on the MU part, right? But the MU part affect by your graphic, right? Your computer, the consume the resource, and maybe sometime if you use just the part a lot of in your process, you never have the drain try to take it out, right? And drain you take it out the object inside of the production line, right? If you use the drain, okay, if the leaf take it out, take it out, take it out, okay, reduce the resource consume, right? Consumption computer. Right now I bring you to the dialog box and set up just only five right now. Okay, enough for this example. Right now I reduce the object press on my display, and right now I can check it, check the data information on my graphic card. It might be quite okay, very smooth, right? And frame per second is add up and okay grow up to 100, right? And before I put in 50 50 and 10 and my frame rate, right? In frame rate to be 6 per 6.9 6 point something 6 point, right? 6.9. Okay, very slow. And right now, when I reduce the object based on my display, my work, right now, okay, go up speed already. Okay, check your computer. I need your computer. Okay, I return back to the start point, that start initially. And when I need to go on and go on about the object, right? I will press the drain, okay, drag down on the drain and use the assembly here, station, and what is assembly station, right? Okay, assembly station. And XP station mostly used with the storage, okay, and like the body, like the partner, used together mostly. Right? Majority the model using the storage and must be have about assembly, and assembly you trick in your idea about everything you have learned before. I taught you in the previous video, and assembly must have the main part supplying the container or the pallet or some container, right? Depend on the graphic, right? 3D model you use, right? And for the dissolve part, use just the container pallet, right? The pallet being object, a main part, right? And the main part also deal with about subpart two, right? Subpart is just another one. It must have the part, must have the component for assembling the bulk at the station, assembly station. Right? There are two, at least, because assembly can assembly can be used more than two components, two parts, right? And main part, right, is just one, and two subpart, right? Subpart, and subpart one or three or four or whatever, at least two, right? At least two, main part and the subpart. Okay, that means I need to drag drop on my project. And this is the supply source, right? The source and the source. I use the connector wire from the source, from the source, and wire soldered to assembly station. And you check it up about connector name. Connector name is one from the main part, right? And these two from the solid and drain and drain. Now check it up by play. Okay. I have never set up some method in the assembly station. How the assembly station assembling two part, what the method assembly station use, right? You must setting up the parameter inside of the station. Okay, let me click on the station, the assembly station, and attribute, right? Attribute. If you remember the previous video, I define the main part main mu that is the one, right? This is the main part default, and I use the predecessor for uh, the previous example, right? Previous example in the video the previous video. I define this one, right? Open and decessor number two, and how many part the subpart, how many the subpart uh, for assembling in the station assembly, how many part, okay, assembling to the pallet, right? Attach the pallet and go on to carry on top of the conveyor, right? Identified by predecessor. And right now I change, right? I change to another option because in the storage, maybe in the storage in the different type of the part, right? So inside of the storage block, right? Storage block, okay, inside a different type, right? Different type is stored in the storage, right? That means you can define by the assembly table, right? About mu type, right? And use the mu type instead of the predecessor. And right now you can define what type you need to pull out to the assembly station, assembling with the main part, right? And you can open. You should open the part, right? Okay, I can drag up on part this one, and number 44. Apply. Apply. When apply done, you remember about the delete mus, mus, and last time I suggest you should use the attach mu. What is the attach mu meaning? If you remember, if I use delete, the subpart is gone, it disappear on the conveyor, because when okay it put out by assembly, right? Assembly pull out from the subpart source to the assembly uh, station and assemble together. And if you use delete and the subpart is gone, and if you set up attach, okay, the assembly right the wheel, right, and one frame part another subpart attached together and go on together to to the conveyor, right? Okay, make sense, right? Make sense. I use this attach, right? Apply. Okay. No, I not yet completed. I forgot the container desktop on here. Right. Okay, again, right here. Okay, four. Okay. I have never display. That means I didn't know about how many part the success in the stable in the assembly already, right? How many the part go out, right? I didn't know, right? I didn't know. How did I know about that? What thing I need to do, right? Okay, you remember what is the solution if you need to display the result and the output and throughput, right? Throughput in the your process, right? Okay, I use the user interface, right? Display and desktop on there, and desktop another page. Okay, at the end, the drain, right? I desktop on display, desktop on display, right? Okay, back again. Okay, one lot, two, three, right? When the assembly, right, pull the pass, right, four pass out, and the resort, right, and the sort, okay, fill in, and it's pull out, and the fill in, pull out, fill in, right. Okay, it's because I set it up go here if you need, right, and never have the interval period time, because when you start up that's supposed to running and already and instantly fill in the four parts inside of the assembly, right, because five and five, right, we come to uh, and five again, five, right, one together we come to 125, right, and start up and fill in four and with another four paste on the assembly, right. Okay, because it's immediately start immediately fill in four, right, in the assembly. You see, right, see four, and inside and fully storage, right, and another four, right. Okay, go on, go continue us about running process. um, is the three model, okay, not clear about when it's out of this assembly station, and what happened is the attached together of the assembly part attached together or not, and what happened when we come out of the assembly is not clear, because when you use the connector and out of this the station and to the drain, and drain is it's gone, right, it's gone, disappear the object assembly. is gone. That means if you need to clear up about what happened after it come out of the assembly session, what happened after that, you can use the conveyor, right? You can use the conveyor. Let me delete it out and use the conveyor. Finish. Delete. Okay. Finish. Connect. Okay, let me adjust the speed, right? It come to 0.5. Apply. Okay, slower. It's very clear when move on the part on the top of the conveyor, move on and carry on to another pace, and okay, pull and push out through the drain. Double click on the container. Now the container become to two, right? I just need one. Okay, it's just only one level, and right, the three x around its x-axis. Fill in the area enough for three around its x-axis, and y2, and just only one height. Right? Okay. I will play again, and you try to observe this process. Right? If I run it, the process, how performance is it in this process? You see, when the assembly part session, the next to the storage, right? When assembly okay, assemble together, and assembly part, the main part and sub part together, and go on, pull out pull out the part to the conveyor, and the assembly part the part is gone, right? Okay, try to call the storage. Okay, come in. The part is come in for four. The station need to assemble together with the main part already. Okay, feed it come in again, feed on way feeding to the assembly part, and when sort the sort look at the storage is being pulled out to the assembly already, and okay, it's lost in the root, the reducing, and feed fill in keeps on way full storage, right? Always full storage, right? And this is called like the push out, right? Managed by push out when the next station is gone, done already, right? And assembling together is done already, okay? And push out, always push out, fill in all the time. It's not, it never have the part, I never have the part uh, reducing anymore, right? It's not reducing because always keep full, right? Keep be full all the time, right? And that means you must lose some area. Okay, you take a pause for keep everything is spare part, right? Keep full, always full, the storage full. Then you must pay about the area. You waste the cost. It's not necessarily waste the cost. You pay the cost for keep everything inside of the storage. Maybe it's not necessarily you not necessarily to keep that at all in your storage. If another way, if you plan about okay when the assembly okay done about assemble together and so they still have enough for push out to the assembly station. Okay, not yet sort okay, not yet, not just come in, not it push out the part fill in the storage, because storage still be enough for supply, right? Enough for supply. Okay, not yet. Save the area, save the part enough for minimum, right? Okay, you can set up minimum of in the storage, right? And maximum you can define the minimum, maximum. Okay, stop, right? Stop. Okay, stop. The storage don't need any more filling into the storage, right? Because enough. This is the criteria minimum. Maximum you can set it up, right? Okay, use the part when your system the estimate next station. Okay, next station don't need anymore, right? Okay, enough for here, and so they enough for supply to the next station, right? And next station it don't need anymore because it's still enough for assembly assembly station enough, right? Because the storage still supply continuously, right? It didn't be got stuck, right? Okay, enough, right? That means you can try to set up the parameter like this because you save the cost in your process, right? In this process, I call that is Kanban, right? It's Kanban system. Okay, you can learning about this. What is the Kanban, right? Okay, you can read everything, right? And make yourself understand the Kanban is, right? What is a Kanban, right? And how does Kanban work, right? Something. Okay, this is the Kanban system. A benefit for the production line and the process. You can read that. And the pen simulation, right? Pen simulation, the robot can be set up, right? Needed on the Kanban system. Right? I said, right? I said maybe the storage enough for supply to next station, like in the assembly station. And okay, storage is not necessary to pull out from the resort fill in its own anymore because the station enough for supply. And when okay reduce supply, okay, the part is gone, reduce from the criteria minimum, right? Okay, you call that resort, right? Okay, call the sort again. Okay, right now in this time you might send the object to here, send the part to storage already. Okay, come in, something like that. By the way, in this time the assembly station feed each one time for four, right? Four parts. Okay, feed one time four part, one time four part, and right. How will it be setting? Okay, feed just only one, fill in to the storage just only one, and right now in the feed and fill into the storage one time for four, right, for four parts fill in to the storage, because the storage is being pulled out to the SMB, and SMB one main part and four sub part, okay, attached together and sent to the output already. And okay, it's not necessary to feed just four, one time four, it's one by one, right? How will it be setting, right? Setting in that this is the idea, right? Okay, it's flexible, right? This is flexible. Okay, how do I do this? If I need to set up the parameters specially in the storage in the assembly to get assembly session. Before I will be setting specific parameter in the two station, one storage and assembly. Before that, I need to look at the data from storage and assembly. To look at the data from the chart. Okay, that means I will bring you to take the chart. Right? Take a chart. Come here. And before that, I will reset back to the start. This one is chart, right? Okay, that drop to chart. Uh, occupancy. Okay, that's good. Yes. And another one, another chart. Again, and drag drop the SMB to the chart and occupancy. Yes. Okay, I changed my mind. I need to delete it out. Is it offered? I need to comparison. Compare to chart. One occupancy, another resort, right? Okay, let me delete it out. And again, come here and drag drop the CB to the chart and resort. Click OK. Right? Uh, the chart display, I will set up. I will be set up this in the frame, the frame attached in the display on the workspace. Right? Okay, this one same display and in frame. It's good. Right? And maybe sometime if you need to rotate, right? Write the chart, 3D chart. You double click on edit, right? Edit and okay, rotate around of x-axis, right? 0, x-axis 1 and 90 degree, 90 degree, right? And press 4, 6, right? 4 is good. Now this one same, edit 3D property, right? And 0 and x, right? And 90 degree, 90 degree, and this 4. Click OK. Play. Number of the MU is contained in the storage, right? 125. It's full stock, right? Full the part in the stock, right? Okay, again. You can reduce speed and okay, speed up. Uh, or you click right, or you double click on event controller and okay, increase and reduce, right. You can adjust by your own, right. Okay, let me reset. If I double click on here, no, here, if I reduce the speed of the conveyor to 0.1 meter per second apply and reset and move again. Okay. The conveyor, right? Conveyor is very slow, and the production line in the block, right? It's a block uh, because it's very slow, and assembly station, okay, everything is done already, but it cannot feed the product to the conveyor because the conveyor is got start on the top of the conveyor, and okay, this is block, right? The yellow color is block process. The process is not smooth, got stuck, right, somewhere in the process, right? And this case, there's a block to the output of the station, assembly station. Let me show display like okay, histogram, right. Okay, not clear when it's display on the chart. Let me use the line plotter. I use the line plotter, it's better. Line plotter. uh, axis. You up this, you find out the length box and change the 100 to become to star is any y-axis scale, right? Any scale, any marks, right? Okay, like star, right? Okay, apply and okay again, and okay, back and play. Here 120, 20% in the storage, right? In storage, it's the storage 100, 20, maybe 75%, waiting, 125 part, right? And actually this process and one time is the assembly station need just only 4 part, and why the keep inside of the storage for 20 125, right. It's a fully always full storage all the time, and but actually in the assembly station just one time need just only 4, and that means the storage is it's overstock, right. Overstock in, you uh, you think about this, analyze this system, okay, not good, right? It's not good because you waste the time, waste the cost to keep this storage, right. A lot is it's overstock, right. Let me think that you're going to control inventory because it's stock is over, then necessity to use enough for next station need, right. Let me duplicate this one. Duplicate means copy to another model. Duplicate, right? Okay, duplicate this storage, and I change to the name Kambang. Yeah. Okay. He keep the old one right here. This is the example. Right, the system push out, right? Okay, push out inventory control. This is the one type of inventory control, but it is not good, right? It didn't save the cost, save the time, right? It like the push out type, push out. When next station done, okay, fill in another 4 plus to the storage, right? And when the assembly is done, fill it again, right? Okay, it's push out the system, the storage, okay, found about next station, it's done already, okay, fill in, always fill in for full, right, for full. Then we another case, right, the Kampang, okay, this station, the concept is the safe used for requirement for need, right? Next station need, okay, keep it and supply to the next station, okay, enough, right? Enough. Safe is not, and it's not over storage, right? Not over, so if the storage is over, okay, it's protect that way. The Kambang is a storage is and tie number one, I close it clear, right? It's close it, it's close, and it's closed, right? And double click on Kambang, okay, it's closed. Double click on the sort, right? And the sort control storage, right? And surprise always when the storage reduce, and okay, done some the part 4 parts done, finish, right? And the sort is supply immediately, right? This is a push up system. I put a system. I call it push up. And each Kanban, okay, it's the opposite, right? Opposite. Let the sort let the storage control itself, control the sort, right? Instead, in the sort is not control supply the part from the sort to storage anymore. And right now, let the storage control sort instead, right? Okay, and the part should be set up, right? And the part should be set up, right? Axis control mu, right? Oh, here, right here, order control, right? Order control, okay. You set up in the sort, right now we come to receive trigger from the storage. When the storage needs some parts more, right? Okay, send the signal to write the trigger sort, okay, let the part come in, right? Let the part come into the storage and end up in the storage. And another storage must be set up by the criteria minimum, right? Minimum of the storage, right? You keep a spare part inside of the storage. What is the criteria for minimum? Okay, right here, control, click OK, and the storage double click, right, up there. Click on the supermarket. Click on the supermarket, right? And click configuration and set up part type, right? Right now I will use the storage control the sort instead, right? And this is a Kanban concept, right? Okay, I need to use type mu type, right? The part, right? Okay, and the name I use part and minimum when the storage reducing, right? When because the next station have done, I have done about 4 by 4 by 4, right? And go on, okay, reducing down to minimum when the part okay reduce less than minimum criteria, okay, send the ticker to the sort okay supply come in, add up add up how many I will say it's 100, add up 100 part to the store again, and okay stop the sort is stop, okay never supply the part anymore, it stop because you fill in 100% already, 100 plus already, right? And okay let the assembly station okay use consume the part for assembling the part already, and until less than the minimum again, and okay put in the 100 part in the storage, right? Okay this concept first. Okay, I control for maximum is 100 initial, you keep initial in the storage 20, right? 20, and what is the sort, right? What is the supplier? Somebody I think it's sort, right? Okay, sort apply. I will try. Okay, okay. Apply again. Okay. Okay. Try. Okay. 100 pass. Reduce, right? Less than 4, and sort. Okay, supply 100 pass to the storage, right? And the assembly use, okay, and assembling two part already and send to the conveyor is keep at output, right? The output okay it's gone, right? Because the drain is delete, everything is down, right? Okay, keep going, okay, reduce less than 4 and fill in again right here. Okay, finish. And the graph, the solid graph, right? And okay, go up and down when less than and reducing less than minimum and the source supply 100 part scroll up again, right? And okay, and fluctuate the graph like this, okay. And this time the storage, right? So it control the sort when the sort supply to the supply the path to the storage, okay. And the sort being controlled by the storage. if I need to compare together with the push out, right? Push out system, and this and Kanban is right the pull out, push out right the normal, and the pull out right the Kanban, right? The control Kanban control by storage, and push out control by sort, right? And I need to recall, right? and look up the graph. Okay, so keep constant, and the sort try to keep the storage full, right? Storage is full because controlled by source. Source is focus on the storage. Okay, reduce the part, right? How many the part reduce? Okay, the source is try to fill in the storage full. Okay, this is a different concept. This is the example for compound system. Let me turn it back. Okay, return and save, right? Save this file. Okay, and go next. Create the new model from right button and go to side. Right? The side is focus on model frame. Create it. Next object I will teaching you. I will be teaching you about the buffer, right? Next object. Uh, that in why do I setting the name right, the buffer. Buffer and close buffer. Going to material 4, next drop the sort. You must have the sort. And going to drag drop the station, and drag drop the buffer is buffer, and drain is keep the output part, and the conveyor. The conveyor. Oh, sorry. Conveyor. Finish. And the connect. Use the connector. Pest control. Normally, if some system and position line there are no the buffer, normally the station can be used the station for one part, right? One part is producing something inside of the station. And right now, if I need to take less area before the station, I keep the part fill into the container, right? The buffer, right? The less area keep and accumulate the some part inside of the buffer, right? What happens if I use the buffer right, before the station? Write it. Look at it there. Sorry, this is the it's not storage. It's buffer. Is the area, less area for keep the part, right? Stay inside the buffer. Okay, you keep the parts inside and keep accumulate the part, right? Go up, right? And in that some part feed to the station, right? And focus on this station. Double click on here, and this one, the option in the buffer type can be queue or stack, right? And queue, right, the first in first out, right? First in, first out something. And this one stack, its stack is different. Stack is different. The stack is the when the first in and last out. First in, last out, right? Something like that. Okay, this is the behavior of two type of the buffer here. Click OK. Try again. Okay. Look over this setting and effect to the production line behavior. Test it up. Check it up. Okay. More quick. It's faster. Double click on here. Reduce. You use mouse. Click on this. Okay, part one, right? Part one. Okay, waiting this one done. Is it done? Not yet. Click on here and focus on the part name and look over, and the part number 2 is because it's queue type, right? Queue type is the first in, first out, right? It's first in, first out. It's number 4. Then back again. Um, okay, run. Okay, this one, different part number 1. Part number 2, right? Part number 3, okay. Number 4, right? Okay, number 6, 7, right? Okay, right? First in, first out, right? Okay, if I adjust the parameter to the stack type, stack type is first in and last out, right? Last out. Okay, if you use the stack and the first part goes to bottom, and okay, and impossible and hard the back hardly feed to the station, very hard, because first in and go down the below and on the top, and on the top is a and go into stack, right? On the part on the stop on the top, okay, have chain have a chain to put in the station, right? Highly opportunity, high chain to put into the station before and before the part stay in the bottom, right? Okay, this is the behavior of the stack. Okay, I will use this, play and look at the part number 1, and next 10, right? 10, you see it 2, 3, and on the top feed to the station, station, right? Highly priority, say on the top is highly priority. Okay, this is a stack, right? And even the very low priority, if the part you say on the bottom, right, this is a stack method, stack procedure, stack idea, right, stack type, right. Okay, if I turn it back and change this queue again and play the priority, right, priority first come in, priority is high, highest priority, right, first in first out, right, going to here 1 9, all right, because in the next one go up, right, here and the go up, okay, right, it go up and select on the second part feed into here, because the first part is, because the first part come in, the first part stay in the only one before the second part, third part is come in, right, first in or here equal station, and another the part number 2, first in first out, okay. This video I think enough for time for this time, and see you again next video.